Everybody, this is the square root of gym squared. Talking to you today about equations that have variables on both sides. This is kind of an introduction. I'm going to talk about the special cases involved. I'm going to talk about how to solve these problems. I'm going to give you a word problem eventually. And I'm also going to tell you what my favorite dinosaur is. Okay, to start, I want to just give you a real brief overview with these equations. And when you see variables on both sides, these kind of problems, first you'll have to distribute. Then you'll have to combine like terms. Then, if you did that perfectly, you will get something that looks like this. 4x plus 2 equals 5x minus 1. Now, this is after the distribution. I'll talk about that later, and the combining like terms. But here, first you add or subtract to arrange variable expressions on one side. That should be one side, and constants on the other. So if I want to add or subtract the variable terms to get them to the right side, I would subtract 4x from both sides. This gets it rid of the left side, and we're left with 2 equals x minus 1. And then if I add 1 both sides, plus 1, I get x equals 3. This is the only difference, these couple steps, as far as our algorithm in solving these problems. If you grab the link that's in the description, you'll find Evernotes for this lecture. I'm about to do the example problem that shows up in those notes. Okay, well, our first step is to distribute. So I say I have to distribute this 2 to here and here, and the 3 to here and here. I'm going to be left with 5x plus 6x minus 4 equals 15 minus 9x plus 21. From here, I want to combine the like terms. So like terms here are 5x and 6x. That gives me 11x minus 4 equals, on the other side, my like terms are positive 15 and positive 21. So that gives me negative 9x plus 36. Now we want to get all the variable terms on one side and the constants on the other. I'm going to add 9x to both sides, and you can pick whichever one you start with. We could have started with subtracting 11x, but this gives us 20x minus 4 equals 36. Add 4, 20x equals 40, and 20x equals 40. Divide each side by 20. X equals 2. I do have to warn you, there's some special cases when you are working with these problems. Our last answer was x equals some number. X equals a constant. They'll look like this. X equals 3. And this means there's exactly one number, 3 in this case, that works to solve the problem. You're done. That's normal. When you have variables on both sides, though, sometimes you get a scenario like this. 3 equals 4. Or 7 equals negative 10. If you get information at the end of your problem that is not true, that it's 3 does not equal 4, 7 does not equal negative 10, then your answer is null set. This is the symbol for null set right here. And you can write also just no solution. SOLUTION, no counting for penmanship. The third type of answer you can get for these types of problems is x equals x, or 4 does equal 4, 7 does equal 7. In these cases, since both values are the exact same, we can write ID for identical. Identity. So If this right here means that no matter what you pick for x, if you it'll solve the equation. Any value will work. So the first special case is just normal. One value works for x. X equals a constant. Another type of solution you'll get is null set right here, and that's no values for x, and your final answer will look like 3 equals 4, which it does not, or 7 equals -10, which it does not. Third example, ID right here, identical on both sides, any value for x will work. Moving forward, I want to go over a couple of problems you've seen for homework. This was from a kutasoftware worksheet. We have -5 times the quantity 4x minus 2 equals -2 times the quantity 3 plus 6x. To do this problem, we have to distribute first the -5 through to the 4x and the -2, and the -2 to the 3 and the positive 6x. -5 times -4 is -20x. -5 times -2 is positive 10 equals -2 times 3 is -6. -2 times 6x is -12x. Collect the terms, one on each side. Notice we don't have to combine like terms for this problem. I'm going to add 12x to both sides. This means I'm going to collect all the x terms on the left because I'm eliminating them from the right. -20x plus 12x is -8x plus 10. Bring the 10 down. Equals -6. Then to move the 10 to the right side, we should subtract 10 from each side. -8x equals -16. Divide each side by -8. X equals 2. That was one homework problem. Another homework problem was 26. Whoop. Oh wait, pause the video if you want to look at my work. Or rewind. Okay, I'm moving forward. 26. 26, similar problem. I think we're going to have to combine like terms for this one. 5 times 2x plus 6. We're going to distribute first though. -4 times -5. -4 times -2x. I'm going to move a little faster. 10x plus 30 equals 20 plus 8x plus 3x. I didn't touch the 3x. We brought it down. Still positive. If I made any mistakes, I'm doing it on purpose. 10x plus 30 equals the like terms that we need to combine are positive 8x and positive 3x. So 20 plus 11x. Subtract. I want to move the variable terms to the right this side. This time -10x to both sides. -10x. Now we have 30 equals 20 plus 11x minus 10x. That's just x. Minus 20 minus 20. X equals 10. Once again, if you want to see that worksheet, I'll have a link in the comments or the description section, but it's kutasoftware. But moving on, everybody's favorite, word problems. So what integer, when added to double itself, equals that same integer added to the next two consecutive integers? You will only see this type of problem in math class, but here we go. What integer, x, when added to double itself, 2x, equals that same integer added to the next two consecutive integers? Did everybody follow that? What integer, when added to double itself, equals that same integer added to the next two consecutive integers? There we go. That's the setup, and I will show you a little bit fancier in the next slide. Okay, so if we build this algebraically all in one line, it looks like x plus 2x. I'm going to change my color. X plus 2x equals x plus the next integer, which is x plus 1, plus the next integer, that's x plus 2. Okay, so, I'm recording still. We have 3x, I'm combining like terms at this point, equals x, x, and x, that's 3x again, plus 1, plus 2, is plus 3. From here, variables on both sides problem, 3x minus 3x equals 0 equals 0 plus 3, or 0 equals 3. But wait a second, 0 does not equal 3. This means that there is no integer when added to double itself equals that self integer plus the next one up plus the next one up. It doesn't exist. This answer is null set. No value for x will work. Tricky word problem. And a special case at the same time. Okay, I know I promised this, but here is my favorite dinosaur of all time. Yep, you guessed it. It's the Ankylosaurus. There's like a turtle, but with spikes on his armor and this club on the back that also itself sometimes had spikes. Maybe that's in one of his cousins, but they would be right here, over here, over here. But yeah, Ankylosaurus, my favorite dinosaur. What's your favorite dinosaur? This has been the square root of Jim squared.